Hi everyone, my name is David Rogers. I just want to say thanks to Steve for accepting my proposal to talk. This came about after a discussion on Twitter about how much security researchers had contributed to this work and whether security researchers were being listened to. And the answer was a resounding yes. But I thought I'd come and explain the whole rationale to the work that led up to the publication of what's called the Code of Practice for Consumer IoT Security, and also kind of talk about some of the implications and hopefully further the discussion with you guys. So as far as I'm concerned, if you've got any questions, feel free to interrupt me. It's a two-way street, so just stop me. I'm sure somebody else has got the same questions here. The background, well, my background is left school at 16, worked in a semiconductor fab doing an apprenticeship, got laid off, ended up working for a mobile phone company, Panasonic Mobile, RIP, and we had a big security incident. At the time, I was designing equipment and software for the factory line, and the question was, that there was a pirate in Lisbon, in Portugal, who was apparently using my software, and they sent me out to Lisbon to go and see this guy. And when I get to Lisbon, it turned out it's this undercover operation. I'm 21. I was like, this is kind of good. I want to do this stuff. So I ended up falling into security. And we wouldn't believe it, but around that time, so about 2000, we didn't have any kind of product security function whatsoever. And this wasn't alien to us as a Japanese company. It's just a reality of how consumer products were built. And it's kind of interesting to me looking back about, when I talked to the design engineers in the design center, that whilst there were all these hacking tools available, and we're talking about embedded systems hacking, nobody even bothered to kind of go and do that search, because mentally that was a different world, even though it's probably just an internet search away. And so we learned over time, how to deal with these people cracking our products and how to design our products more securely. And so a lot of that work led to massive improvements in the mobile phone industry. And so there was some work that led out of that called TR1, which was from an organization called ONTP, which led to the standardization of something called the TEE, Trusted Execution Environments, in every mobile phone now. And actually, mobile phones are a very, very hard target. We kind of had our moments, as it were, but the mobile phone industry is certainly much more mature than most other connected product industries. Sadly, the same can't be said for IoT. IoT is generally an easy target. So as we've grown historically in the mobile phone industry with the attackers, so our defense has got better, the attackers get better, we get better. So kind of we're up there together. And then you've got, say, a washing machine company over here who goes, I don't really want to go the way of the dodo. Boardrooms are a bit scared. You hear the word Kodak kind of thrown around boardrooms. Right? They're desperate to not be obsolete by some new company. So their answer to that is to connect it to the internet, because that's what people want. And it doesn't matter whether the use case is valid or not. It's all about digitization. So you hear a lot about that in the connected industry world. Digitization of non-digital companies. But the problem you've got is this company, and I'm not just highlighting washing machine manufacturers, there's a ton of other consumer products out there, but they don't have a clue how to do anything securely. They don't have a clue what to do when this thing goes on the internet. They're buying in third-party hardware. They're probably having it integrated by some kind of third party. They're getting the app developed by a third party. And all of that creates what essentially has been a perfect storm. So how this work originated, so I do some work for DCMS, it's a government department, and they have a role here on cybersecurity. I do some work on standards and so on. And I was tasked with creating this code of practice for IoT security, along with a lot of very, very clever people from the NCSC and the ICO and other parts of government. I was going to go through a bunch of slides with examples of things like cloud pets and connected fish tanks in casinos and stuff like that. And to be honest with you, I couldn't be bothered. So you got a picture of my cat instead. This is Pumpkin. If you play Neko Atsumi, this is Pumpkin too. Pumpkin's named after Pumpkin. But I thought I was kind of looking through for pictures of my cat this morning. And I thought this is actually quite a good one, actually. So this is, I guess we can say, well, this is BitFi. This is Cyber Gibbons. No. This is Ken Monroe. This is IoT. But there are so many examples out there. We all know them. That's why I didn't want to kind of, teach my grandmother to suck eggs. We all know where these issues are. We see all of these products. And we're not actually surprised when we see that yet another crappy piece of IoT is being hacked. Those companies that are hacked seem to be surprised. Obviously, we've got a biased sample here. But in my experience, and I run a company, when we get people ringing us up saying, my product's been hacked and what do we do and so on. Give you a couple of examples. So one was a very large webcam vendor. I think it was Context had actually done a free public pen test and published the results. Scott Lester did a great job on that. Company rings us up and says, we want a pen test. I'm like, well, here's the pen test. You've already got the results. They're like, no, we want a pen test. I'm like, well, you need to redesign your product, right? You need to, first of all, you need to fix the problems that you've got, but you do need to redesign your product. No, we want a pen test. And this conversation went on for about 20 minutes, and then the company eventually went away. And this is not an uncommon conversation, is that most of these companies that get hit, all they want to do is make the problem go away. I had another company which created kids smartwatches, and the founder rang me up in tears. We need some help. So, okay, here's what you need to do. You need to redesign your product. But this one was quite interesting because what you see, a lot of these products are kind of badged ODM products, so outside design manufacturer, and they're coming from Shenzhen, somewhere in China, and then the job of the entrepreneur in Europe is basically to get it into the sales channels of big retailers, right? So the entrepreneur doesn't actually care what that product contains, nor do they know a lot about it at all. But the problem is that that reference platform that's being used for, say, that watch is the same across all of those different watches that are sold. And I kind of, people throw around the word backdoor quite a lot, but I can't quite work out in a lot of cases whether it's just a cultural issue that there's a lack of understanding that you can't just have an open remote diagnostics function with all of the development commands over SMS. There just seems to be like a massive mentality issue here. And then, surprise, surprise, the company's getting really upset because somebody's published the list of commands on the internet. And it's like, well, you're kind of focusing on the wrong problem here. So And this is stuff that we see over and over again. Actually, coming back to mobile phones, for those of you who were at DEF CON, oh sorry, it wasn't DEF CON actually, this was at Usenix. The sort of expose of how many people had left hundreds, and in some cases thousands of AT commands left wide open on mobile devices, still just sat there. So it's you know, it's not unique to IoT. But we just see the same problems time and time again. And this is stuff that we've all been talking about for 20, 25 years. And it's still going on. So when we had these meetings, we had an expert committee that was put together. There was loads and loads of different companies consulted. People like myself were talking to researchers around the world. I'm regularly going to security conferences and so on, talk to a lot of security researchers. But it was interesting at the table because you get the same old things trotted out. What we've got to do is educate the users. Or, you know, some fanciful thing about quantum computing and, you know, maybe we should make these things quantum resistant. And I'm kind of banging my head off the table at this point because actually the broad problem that we've got, and this is highlighted by Mirai, is that we're not even bothering with looking at the basics because actually the basics aren't that sexy anymore. But there are still manufacturers, a huge amount of manufacturers, who are doing really, really insecure things. And actually, we've probably reached the point where we just need to say, no, it's not acceptable. We want to eliminate this stuff. And we're going to say that we will not tolerate it anymore. And we kind of got some consensus on that. Another cat picture here. So I guess, yeah, the reason for this is we all know what's going to happen to these IoT products, right? And it did. So the background to the Secure by Design work is, so in the UK we had the National Cybersecurity Strategy. So that the first iteration of that was sort of worked on in 2010, 2011. And the core of that was really to say we want, our aspiration is we want the UK to be one of the most safe places in the world to do business, to work in. We want the UK to be an exporter of you know, security goods and services. We're already pretty good at that. And also we want to build the skills base. So we want to encourage universities and so on. So I teach at a couple of universities and we've now got the GCHQ's certified degrees in system security. We've got various cohorts of PhD students around that are already coming out, funded by DCMS. So we're starting to see the results of some of that investment. But there's a second iteration of the cybersecurity strategy which started in 2016, and within that, we also said that the UK is more secure as a result of technology products and services having cybersecurity designed into them by default. So what we're saying is, you know, it's an acknowledgement that you can't just add security as an afterthought. That actually we do need that design mentality shift to say this thing is going to be properly secured and we're going to invest in a secure software development lifecycle. We're going to actually think about security as we build these products. So by implication, we need to define how we're going to actually do that, what are the tactics to actually achieve that. So a review was conducted, the Secure by Design review, and it looked at two key risks related to consumer IoT. So the first one was that the poorly secured IoT devices and services increasingly threaten consumers' online security and privacy and even safety. Don't think anyone will argue with that. But the second point addresses a slightly different slant on this problem, which is that poorly secured devices in homes across the UK can end up being hijacked and be used as part of an attack on something else. So actually the user may see no effect. And that is a greater problem for the country in some respects. And so, we saw with Mirai, there have been other IoT botnets like Reaper and so on. But Mirai obviously had the biggest impact. 1.2 terabits per second at one point against Brian Krebs, I think it was. It does show the resilience of the internet, actually, though. I mean, okay, 24 hours of pain, but kind of bounced back. Internet's still running, wasn't broken. And so the back end of this was that on March the 7th, we launched a report at which kind of contained all of our efforts on this. And at the heart of this was this code of practice on IoT security. There was a public feedback phase, so that went on until the end of April. I think Steve said he was going to feed back to it. Had lots and lots of interesting input from companies and individuals, from associations representing different types of industries. Because even within consumer IoT, you've got kind of individual, what they would call verticals of things like children's toys. And there are certain sectors that, children's toys is a classic example. So the good work that Ken Munro's been doing to highlight issues with the Kayla doll and so on, or Troy Hunt with Cloud Pets, all really focuses attention. And I think the toys and games industries have actually woken up to the fact that maybe putting kids' toys on the internet might be a bad thing. Could have told them that. But anyway. Within this report also, there are other aspects. So about education and so on, about things like labeling, how do you communicate to the user? Things like skills. How do we skill up an SME to understand how to implement security, for example? That's available to download. You can have a look at it. The code of practice is quite detailed, and I'm going to show you some detail here. It's quite nice to be in front of an audience that understand the detail. And the final version, based on that public feedback, will be published later in the autumn. And I'm kind of pleased to say, actually, that the feedback that we received was amazing, by the way. But substantially, the code of practice hasn't changed. There seems to be broad consensus that we kind of hit the right areas. There were a few things that cropped up. I was like, oh, yeah, didn't think about that one. There's misinterpretations of things. So, for example, if I say outage, in my head, I'm thinking network outage. But to a different set of people, they're thinking power outage. So just kind of cleaning up language, stuff like that. But I think it's all made it more robust. So we concentrated on three main areas, and this is really important to know that, these top three are what we are really concerned about. And so how this originated with the code of practice. So I was at a meeting in Etsy in the south of France, and there was a guy from the NCSC with me, and we sat down outside, and literally the conversation was, how would we have stopped Mirai? So that's how we started off for building up the code of practice. So the devices that were part of the Mirai botnet were accessed through port 23 and telnet using 61 combinations of default usernames and passwords, right? So can anyone guess what the first one in the list was? Admin, right? So I expected you guys to get this right, but actually, if you speak to any, I'll say normal person, any normal person that's not us, they'll also give you that answer. Everybody knows the problem. The problem is staring itself in our faces, right? We know, everybody knows. So why have we still got this situation? I can tell you now that there is a manufacturer producing products today with a default password of admin. Guarantee that. And the rest of all of those passwords that are available. This is not confined to just consumer devices. We've got routers, we've got industrial equipment, and so on. So why are we tolerating it? We don't need to. So let's get rid of it. Let's stamp it out. There are other methods for authenticating to devices. We've established what those are. There's guidance available, there's standards available already. So let's, it's not like there's no solution to this. The reason that people do this is because they're lazy and it's easy. And because everyone else is doing it. So if we make it unacceptable to do that, maybe even if we regulate in the future to prevent that happening, we can stamp this out once and for all. And, there are campaigns. I mean, if you look at people like the FIDO Alliance, they're quite keen to eliminate the password. I don't think practically we're going to eliminate passwords. They're kind of useful in certain circumstances. But this is an actual problem that is actually causing harm right now. So if we have the power to deal with it, then we should. So that's why it's number one. Number two, and to be honest with you, this is quite hard fought, was to ask any company that's producing an IoT product or service to actually implement a vulnerability disclosure policy, preferably CVD, coordinated vulnerability disclosure, and actually act on it. And we do say, and act on it. So we have the beauty of the fact that people like Katie Missouri, who set up CVD in the first place at Microsoft, has really pushed this forward. And it's even standardized internationally. It's standardized in an ISO standard, which is freely available and downloadable. But it's also a recommendation that's been taken up by the mobile phone industry through GSMA. The IoT Security Foundation recommend that you implement CVD. So again, it's within our power to say to companies that we expect you to implement a CVD policy, because actually if you have no point for anybody to report vulnerabilities to you, then you're probably not going to start to fix them. But as Katie also makes a very good point repeatedly, it's no good just implementing a policy or implementing a bug bounty scheme, for example, if you don't actually clean your own house up, if you're not actually actively implementing process measures internally in your business to clean up bugs, clean up your code, and actually close down security vulnerabilities. But it is a big step forward, and it actually forces these companies to take security researchers seriously. So many of you in the audience, and I'll include myself in this, have been stonewalled by vendors when we've reported disclosures. Actually, that's unfortunately quite a successful strategy for them, unless, if I disclose something, I'm probably not going to go full disclosure, if I'm honest. So I do sit on things, and that's usually mainly just a personal thing because I don't want to kind of cause loads of consumer harm. But it is a reality that actually most researchers are forced to full disclosure just because that's the only point at which a vendor will do something, once they're shamed into it. But actually also I would say that some vendors are getting quite adept with their PR machinery. So whilst there's been some good work in the community in terms of highlighting companies where they threaten researchers, for example, which is very common, that usually will backfire on a company from a PR point of view now, thankfully, due to us. But sometimes, you see security researchers being smeared, or the other one is people getting no fixes, and then a company quietly fixes it, puts out an update, doesn't acknowledge the researcher. I mean, real bad practice. So, that term of responsible disclosure that we kind of want to get rid of. What I see is more bad practice on the corporate side than on the researcher side, if I'm honest. And there's still a lot of education to tell these vendors that actually if somebody discloses something to you, that's a good thing, and you're probably dealing with a nice guy because the bad guys aren't going to disclose it to you, they're just going to use it. So, we did some research recently. Didn't surprise us that there's probably around about 90% of the market has no form of vulnerability disclosure policy and no way to contact those companies. We need to clean that up. I heard some interesting comments on Twitter about people talking about, well, what if a company doesn't respond to me? Maybe the next step should be that I can report that company to the government and the government can actually do something about it. And I think some of those really interesting ideas, and I think the people like the NCSC are very well aware of this. And they're also working with Katie Missouri on the government disclosure scheme. But we'll continue to develop this as we go forward. The third point is about keeping software updated. So this is by no means trivial, but I would say that I think this is like the sort of single greatest thing we can do in terms of cybersecurity hygiene. We shouldn't leave these vulnerabilities open. If you look at what happens when you do keep your devices updated in the field, what you do is basically you don't allow that kind of incubation time that allows the sort of commoditization of tools to be created for vulnerabilities that are left open for years. So if you shut it down very, very quickly, you shut off the exploitation routes. If you're fixing vulnerabilities before they're found publicly, wherever it is in the stack, it might not be exploitable now, but you're just keeping a clean ecosystem for everybody. And so I've done a lot of work in the mobile phone industry on that. Google have done huge amounts of work to drag vendors kicking and screaming, if I'm honest, to a better situation. It is better, but we can't say the same for IoT. And IoT does carry its own challenges. So there are super constrained devices out there that you may never be able to update, so we had to consider things like that. But I would say for the vast majority of devices, they can be updated and probably should be updated. But we have other challenges, things like, these devices don't have user interfaces, they're headless. So how do you communicate that to the user? How do you manage all of these devices in a household where, you end up with, say, 60 devices that all need updating at various times? When to update, right? If you look at the Internet of Shit Twitter account, which is, by the way, the greatest public service to the Internet of Things that I know. The latest tweet was about watch updates. So one of the things we say about updates in the code of practice is that the core functionality of a product, so a watch is a classic example, there's a user expectation that a watch should at least be able to tell the time. And that's a very, very basic example, right? But when it comes to safety critical, it gets a bit more interesting. So the story that I often tell people is just before Nest was acquired by Google, like 2 days before, there was a tweet to Nest saying, thanks guys, your latest software update turned off my Nest and froze all my pipes. It was in January, the thing shut down, stopped keeping the house warm. And you're like, how does that even happen, right? But the reason it happens is people design things on a bench and they don't actually think about the real world usage. But, when it comes to IoT, we can't accept this kind of failure now because actually the failure modes end up being safety critical a lot of the time. In fact, a lot of IoT devices you might not even consider your IoT device to be safety critical, but somehow it links into some other system, and suddenly you get safety critical scenarios. So there is a concern by a great many people that will end up with the first directly attributable death to IoT. So it's incumbent upon us all to try to avoid that. You know, we don't want to victim blame, right? We don't want to victim blame vendors who are hacked because of no fault of their own, you know, no major negligence. But what we do see is a lot of negligence now, and a lot of things that will be safety critical. So the good thing about these is also they're kind of measurable. So we wanted them to be outcome based. So to a certain extent, all of these three things, even by a user, could be checked. And I think it's reasonable to say that if a vendor doesn't have those things, then you're probably well within your rights to say, I don't want to buy it. Because that's the tip of the iceberg. The rest of the things are probably going to be unsecure. But we've still got a long way to go. That 10% at the top that I mentioned, the 10% of the market that is doing well, are doing a responsible job. And I would say that probably they meet all of the different elements of the code of practice. And if they don't, they're probably very close to doing it. So then the rest of the code of practice tries to be pragmatic. As I say, it's aspirational in some cases, but it's a recognition of stuff that we probably already know. Things like, you can't build a secure IoT product unless you have secure hardware, right? There's no, you know, we can't just randomly build these things and expect it to be okay when it reaches Andrew Tierney, right? Somebody. So, again, we've all seen these examples of people obfuscating passwords that are hard-coded and expecting nobody to reverse engineer it. So if you don't have if you don't have secure storage on the device, if you don't have hardware security, then that's what you're going to get, is a developer's got nowhere else to go. So they're going to have to try and do something that they think is clever, but clearly isn't to an advanced level attacker. So I'm pleased to say actually that there's quite a few platforms that are starting to come to market now that are including things like TEEs and secure storage, and also abstracting away some of the difficulties for developers. You might have seen recently as well that Google released a more simplified crypto library, basically trying to avoid obvious pitfalls for developers. That's the kind of thing that we need to see. You know, cryptography is hard to implement, and there are many ways that can go wrong. We talk about communicating securely. What does that actually mean? Well, in a lot of cases, if you ask Ken Monroe, for example, lack of certificate validation is probably one of the easiest ways past a seemingly secure connection. But if you go to Stack Overflow, you'll see lots of nice comments that say, you know, how to disable certificate validation in HTTPS connection. And there's a comment that says, thanks, you solved my biggest problem in the project. Because this is kind of thing that this is hard, the developer's up against a deadline, but what you've done is make the errors go away. And it's also hidden, particularly if it's in a mobile app, right? Because the user can't see. There's no visible warning or anything. You know, we need to ensure that these things are implemented properly, and I was pleased to see that Google announcement. Minimizing exposed attack surfaces. You know, these things are things that we've said before, but these things that are acute reality. So, you know, you shouldn't have remote diagnostic functionality. You know, we need to wean people off the fact that they want to see this thing again once it goes into the field, just in case they screwed up and they need to kind of mess around with it a little bit. Actually, companies need to think about that from the start. Do you really, really, really need that remote maintenance function? Or is it just going to become a vector for hijacking? But that applies also to hardware, right? So the amount of devices that you see with things like hidden serial ports. So I saw on a femtocell, an HDMI port on a femtocell. Like, yeah, why? Well, clearly it's just a hidden serial interface. Now, the company has thought, we're clever, yeah, nobody will ever guess this. But clearly, it's just stupid. It's a waste of time. It's a waste of time putting that adapter on there. But they're putting it on there basically for maintenance in the field at some point. But do the economics really work out? Companies aren't really thinking about this. They're just thinking, for some future point, we maybe need maintenance. But actually, what they have done is just created an easier way for somebody to get in there and attack the device. The same with JTAG ports, right? So again, companies don't realize that, you know, security researchers are well versed and there's loads of tools like JTagulator out there and so on. So, you know, why are companies leaving JTAG ports on PCBs? They could actually remove those. They could have it in manufacturing just on the biscuit, and that's then broken off. Why are these things not properly authenticated? The same with open ports, right? Why the hell have we still got devices out there with Telnet open, right? It's just utterly ridiculous. So ensuring software integrity. So, well, we've got a hardware root of trust in there, so that means that we can do secure boot. Now, secure boot is really hard to implement, but at the end of the day, if I turn my device on and I can't be actually certain that nobody's tampered with it since it's been off, then I kind of lead myself down the inevitable road that actually I do need secure boot. I need to be able to have a point which I can trust, and then I can build up more trust as I load up the code blocks. The tools are out there to do it. The software's out there to do it, right? But people don't implement it because it's not, you know, they just don't think about it. But we could eliminate a lot of cold boot attacks just by ensuring that people actually use secure boot. But again, we need to make sure that the chipsets are available that provide that functionality. Then woven within this, so there's a number of requirements that allude to privacy and data protection. So when we launched this in March, we had, you know, we were pre-GDPR and pre-DPA 2018. But the text is essentially aligned to GDPR, and what you'll see in the autumn version is that we do directly refer to GDPR. And actually that makes it very powerful, and I'll come back to that in a second. I talked about outages, but this is, again, something I've seen out in the market, is that actually designers don't necessarily think about the fact about when this device goes off or when there's 1,000 of these devices and they all turn back on after some kind of big weather event. So this is something that happens repeatedly on mobile networks called signaling storms. So actually being able to deal with that situation, how to deal with devices when they're offline. So it amazes me how many devices that just think that they have, the designers think that they've got a continually robust internet connection. That's just absolutely ludicrous. So particularly from a safety perspective, the core functions of that device should continue to operate even if there is no network. We should also consider that you're probably going to lose power at some point as well. This seems like a no-brainer, but if you're getting telemetry data off a device, now there's a GDPR point to this as well, that you probably shouldn't be collecting unnecessarily data if you don't need it. But if you are monitoring system telemetry data, then it's kind of a no-brainer that you'd actually also monitor that for security anomalies. So we want companies to think about that. This one comes from GDPR 2, which is about making it easier for consumers to delete personal data. And that's about the consideration of, if somebody sells a device, or if they give it to their friend, or even, the easiest one is a hire car, or if you're selling your car, right? You need to be able to satisfy the consumer that their stuff is not on there anymore, and it's been securely removed. Security usability, so something that people don't think about a lot, but we want to encourage designers. Now, unfortunately, there's not, the best book that I can find is from 2004. Maybe somebody needs to write the Great Design Patterns book for usability for security, because actually we can eliminate a lot of security issues through cleverly designed interfaces and not leading the user down a track of insecurity. And if you buy devices now, just think about it when you're in the setup process. Is this actually easy? Is there somewhere that we can go wrong? Does it deliberately lead me down a path of insecurity? And in a lot of cases, it does. Even the user manuals are just unreadable. They don't tell the user anything about what they need to do in terms of security. And then the last one, and this is about ensuring that data is not being manipulated across interfaces, right? So we've all seen it, but this is everything from user interfaces through to interfaces between different types of systems, right? So again, this is consumer focused, but example from the automotive world, where data is transferred from most to the CAN bus, and nobody was checking what data can and can't go across those interfaces. But even to extend in things like, is a temperature sensor sending data that's out of the possible physical range of that device? Then maybe there should be some checks in there to make sure that no data can be sent, or that it's a numeric integer between, minus 30 and plus 32, or whatever it is. So together, hopefully this will create a more secure world for all of us. So the government's clearly said as well that we're looking at regulatory options. So we've said what we want, but then we have to think about, well, how are we going to regulate that? And actually, there's some regulatory tools that are available to us. GDPR is actually quite a good one now. In many of those scenarios, there's probably a case to say that that product shouldn't be on the market. But we need to keep exploring those. In the areas of things like product safety and the Consumer Rights Act, there are possibly some levers that we can pull that could really be the big stick. So, some people, I've had this conversation with Ken Monroe quite a lot, talk about enforcement. Yes, I think everybody agrees this, but we kind of need to explain to, you can't expect, if you haven't said what you want, you can't expect people to be doing that already, right? So we have said what we want. And I mentioned about the disclosures thing as well. Perhaps that's future work, If companies don't respond, how could the government help? So our ultimate aim is to stop this stuff getting into the market. There is a huge amount of good. Some companies doing very, very good, but bad companies are actually creating fear in consumers about buying that stuff. So the big companies who are doing good should be actually promoting this and saying, well, this is what we want to do. Communicating that to customers is very difficult, but actually saying to people, being transparent about what you do and how long you're going to support software updates for and so on, that's a good thing. Giving people more information that they can understand may influence their purchasing decision. And yes, it may be difficult for a company to say what the end of life of their product is, but they can make some kind of meaningful statement. They can make some meaningful statement about this product was designed with security in mind. We're not saying, we don't want to say, this product is secure because it was certified at this particular date. That's not going to work, right? Because devices are continually updated, new vulnerabilities come along, new things are discovered, new attacks are discovered. So we need to move away from that kind of static model, but actually think about, is this a continually responsibly designed product, and is it well maintained? Just briefly on the last point, we're also working on some mapping, and so the idea of that is to, we conducted this work during August, but is to map existing standards. DCMS is not a standards body, but there's lots of good standards out there and lots of good recommendations. The problem is there are a lot of them, so we've been doing a process of mapping those, and it's been a huge piece of work. It's about 4,000 pages we've had to go through of various different things. But the good thing is there's a lot of alignment. It's just people say things in different ways. But that will enable us to kind of sort of remove that from the equation, because we've done that work, and we're hopefully going to make that available as open data as well for people to work on. This just shows the sort of level of complexity in the ecosystem. Again, we're hoping to make this available as open data for people to use, and we're just using a tool here called Kumu. I'll probably continue to host this so people can use it. So hopefully, maybe I'm putting security researchers out of a job, I don't know. But maybe we can just relax a little bit. But hopefully it's going to succeed in the market. We're also looking at changing government purchasing to request products that comply with the code of practice. So that's hopefully going to be a big leg up. But we have to also think about how are attackers going to respond to this? How are the vendors that are not invested in actually doing this, how are they going to react? How are they going to try and get around this? And so we're going to continually be watching this. It's going to be under continual review. But the good thing is, for being British, that actually Britain is kind of standing tall in this. We're really, really taking leadership on this. There are a lot of countries looking at this, but Britain is way far and ahead of a lot of countries. So hopefully we can take the lead and show others the way, and hopefully other countries will align to this work as well. And then we result in the defragmentation of this space as well. So thanks for listening, and I hope that was useful for you.